Wait, what? Anyway. Okay, so I don't know why my voice is not how it's supposed to be. Let's just let's set up again. So the regate. Yeah, I don't know why. I don't know why I cannot preview my effect. Maybe the attack should be like 3 milliseconds, so I can like speak in much faster response. And pre-open, yeah, pre-open is good. So yeah. Okay, let's have more more treble. Well, the bass, I think it's okay now. Okay, so I will not be using compressor today because compressor will compress my voice so much that I cannot work on it at all. Like yesterday, I don't know how you hear my voice, but yeah, it's that. By the way, welcome to the stream, Kuma-san. Let me try set up more. Well, expanded. Retails. Wait, what? What does? Oh, okay. Okay, so recomp. So the compression ratio is too high. And I should limit my output, I guess. And expander, I don't know how much should I expand. Okay. Yeah, I think detect should be sidechain, and it works now. Think about it. Oh, okay, so that's actually works. Detection should be peak, I guess. Yeah, okay. The attack, well, okay, so the attack is too much, I guess. Let's go to the default, which is 30 milliseconds. Hey, you guys don't see my screen right now because I don't want to show it to you. But anyway. Okay, so today we are getting into the code. Should we review? Okay, so we should review it first. But I didn't turn on. I didn't open the project file. So let me do that. Maybe you can see my screen record. I have to show the chat. Is this the correct video ID? I think. Video ID is this. Yeah. So there you go. The chat. Okay. Now, what should I do? Oh, right. You guys see 3 names, right? Well, up to the time of the year. By the way, if you think that I can speak in much more understandable English, it's just that my first live of this not this year, but this period, which is like past 4 lives. Yeah, past 4 live streams. I had social anxiety. That's basically all. And actually on ML part 1, reinventing ML part 1, that's to social anxiety. Well, yeah, just like that. Okay, let's recap of what we had right now. First of all, don't divide and don't divide simple threshold and action state Boolean, which actually these 3 things, these first 3 here, are actually it's actually the same thing. Now, last time we explained reading neuron patterns. So yeah, just read the entire brain for a moment. Evaluate output streams. Evaluating output stream. Well, to be fair, that means it outputs the stream. And we are not talking about creating a process that want to process the stream. We are talking about the process to outputting the stream. Not to output thing. It should be to output the stream. And the secret sauce, which is this. No, sorry. Which one? Wait, why the accents here? Oh, okay. Okay, so the secret sauce is the functor. The functors is actually the execution process. These feature actually, like, I don't know, it could also break the system, and it could take like 3 years to write. I don't know. No, sorry, it's not taking 3 years. It will be like maybe a simple functor is adding the data stream. So yeah, adding the data stream. What is this? strings of data. Yeah, string and streams of data, just like picture frames hanging on the string, and you just read through the the picture frame one by one. That's the stream. That's the data stream. I mean, let get me back to this. Hey, wait, what? Why is it so small? Hold on. Yo. Okay. So I want to add to this. The stream actually means stream. The stream actually comes from pipes. Yeah, the stream actually comes from pipes. When this is when two process P1, two processes, computer processes P1 and P2, when they want to talk to each other, they are talking through something called a pipe. And the streams flows here. This is stream. So what classic computer scientists think is this. The data is like a water that flows in the pipe. Yeah. So yeah, this is the definition of stream. And the stream will have many properties, like the actual pipe, the actual physical pipe, including high watermark, and the buffer. So yeah, so reservoir, a reservoir, a reservoir will have pipe, and they will have high watermark, HWM, high watermark, to suggest no water should flow. Actually, the high watermark isn't here. The high watermark is on the output. Actually, they are all on both sides, but yeah, mostly because the outlet is much slower than the inlet. That means they fill up much faster, so we don't have to care about the inlet high water mark. By the way, the reservoir is the buffer, and the maximum of buffer is high water mark. That's all. Okay, so you guys now understand advanced programming concept called streaming the data. Now, streaming the data sounds a lot like this. Synapse, right? So yeah, wait. Where is it? Okay, so synapse. Yeah. It sounds a lot like synapse. So we can string these brains together because the process, like like the data stream. Now this is where the stream cut off last time because I didn't monitor the stream. Sorry. Okay, so yeah, I want to make change to the definition of this energy because the stream size, well, no, not the stream size. The word same output, which I define data stream. Well, if it use different data, if the energy is not equal, the output cannot be equal because each data point will be different, and even though all the data point at the end of the stream looks identical, but the energy level will be different. It will be the same only if it is the different data. So if the stream has the same length, the only way that it will have the same results, if the energy if the output stream has the same length, the only way that the energy can be the same is they are all different data. And if the result at the end of the stream looks identical to another end of another stream, the only way that it will have different energy is that the stream must have different length. So the energy is like a determinant of the data stream. But that's okay. So it cannot have different energy for the same output, the exact same output. They cannot do that. So how do I know that it actually it actually have different energy with the same result? It cannot be the same output. So first of all, I have to write this down. So same data stream means, so the same data stream means the same energy, same activation pattern, same activation. Oops. Pattern. And that means same energy. Because the energy is defined by activation pattern. So what did I got wrong last time? What I got wrong is that I just forgot that the output can be the same even though it has different length. I mean, the output is not the same, but the result is the same at the end of the output. So instead of the same output, we define it as the same result thing, the same partial resulting patterns. What does that mean? Yeah, what does this mean? It means that for any output, there will be different patterns, and any partial pattern that results in some output, in some measure, in some desirable output, will be considered the same partial resulting pattern. So the data stream, I will say D stream here. The stream has this much length, and now we have this pattern. What should we use pattern? What should we use for pattern? I think I think little phi. So this is phi 1 and this is phi 2. Phi means 5 if you are actually like want to say that. So phi 1, phi 2 and phi 3. Sorry. Phi 3. So we have the resulting stream with 3 patterns, 3 recognizable patterns. And we have another stream that is exactly like this. So this is D stream 1, this is D stream 2. So if we were to optimize phi 2, we would choose data stream 2. So for phi 2, well, I'll use this big O. Phi 2 is, well, let me use this for phi 4. Okay, so it's the stream 2. Yeah, so if we want to optimize, by the way, big O means best case. best case, or optimize. So big O v2, big O of v2, big O of v2 is d stream 2. That's all. This is the new definition of using of a better model. For mathematicians, this one should be min v2. I'm sorry, I just started in software engineer. Okay, so one. Well, I will 20y simple threshold. Yeah. So we have seven things to keep track of. So we have no division in the node. In nodes. Two. Well, 2 and 3 answers each other out. The answer is each other. Well, let me use less, like use smaller pen. Like 4, 3. Oh yeah, 3. So 1. No division in node or synapse. Well, synapse. Well, synapse calls functor, so does that count? Well, I think that counts. No, that isn't count. That doesn't count. So because the functor is only activated by nodes, and it will be working in the next synapse. Not the next synapse. It will be working on the next tick. 2. Simple threshold. So linear or sigmoid. Sigmoid functions is actually like a very simple function. Sigmoid functions. See, this is the sigmoid function, and it has division. It's a logistic function, actually, and this is the implementation. So we don't want sigmoid then. So we want linear function. We don't want sigmoid. 3. So because we use linear function, so we count axons activation. Well, these are actually the same the same list. It's actually the same thing. Count axon activations. So the problem is it will overload. So we have to like learn by nodes, by manipulating nodes multiplier, actually synapse multiplier. So yeah, nodes assign synapse multiplier. Well, that sounds exactly like modern ML, doesn't it? By the way, if you think that I don't celebrate Christmas or I don't celebrate any special event, well, yesterday I celebrated Newton's birthday. Well, his birthday is like about at night of 24th, so 24th December. So it's about that. I don't know exact time. No one knows. But we agree that Sir Isaac Newton was born on Christmas Day. That's all. So I celebrated Christmas yesterday. Well, why yesterday? Why not today? Because a lot of people do it today, so I don't care. And I actually don't care of Christmas. I care Newton's birthday. That's why. Anyway, Merry Christmas again. And maybe New Year wish, I don't know. Just Happy New Year. Okay, so the 4th. Oh, this is the 5th. The 4th is reading the pattern. Okay, so the 4th is that we take snapshots. Take snapshot of the brain. And 5, we string these snapshots together. So yeah, what should I say? and process in one stream. Six, the functors. So what are functors? Functors are functions that manipulate the brain. So it tries to change the brain structure. Change. It also change brain local environment. What does this mean? Change brain's local environment. It means, well, mood. Yeah, it just means moods. Okay, brain structure. So property. And also perhaps calculation. For this one, I will leave it for like advanced ML. I don't want to care about it. Wait, how many types of functors we have? We have output functors. Yeah, output functors. Doesn't make sense. Synapse. This one is actually the number 2. Yep. So the reason these two are different because this is synapse, but this is activations. It's actually not axons activation, it's actually neuron activation. Neuron activation. Okay, so I think functors are just that. Oh, by the way, we also have enzymes, which is delegate process. Delegated processes or async. It actually enzymes. So number 7, what was it? Okay, so fitting functions. So fitting functions. Don't drop. Yeah, actually. Doesn't. Whoop. Drop. Table. Star. And also use less energy. Wong lep. Sorry, parentheses. Parentheses. Big O. Oh, actually mean peacock. Sorry. Mean recognize. No, actually, how do I write this in one sentence? Minimum energy. Minimum total energy with respect to, okay, minimum total energy, minimum of some axon. Actually, it should be activations over time. This is the length of this. No, not the length of the stream. This is the size. No, the checksum of the stream. Minimum checksum of the stream with respect to, I guess this one is the best, with respect to optimizing the target pattern. Yep, the target pattern is also the same as the checksum. But the target pattern can be like anything. It can be partial. It can be the whole stream. So, okay, so this one actually means, so it actually limits. Oh, it's actually the limit. Hold on. Yeah. So So it means limit total energy close to target energy level of the pattern. Yeah, so we have another 30 minutes to write codes. Let's get it done. Export. Well, also I want to change the name of this board. It shouldn't be chalkboard. It should be neon board. Okay, wait, hold on. Before I delete anything, this is export. Neon board. Everything is the same. Good. Okay. So this is neon board. Yeah, just save and export PNG so we can work on it. PNG, okay. By working on it, I mean working on it with the less memory footprint. Let's close this. No. Okay, so I will have to go here. neonboard.png. By the way, we should delete this chalkboard and this temp. Yep. Okay, so wait. Oh boy. What is the size? Whoa. That's so small. Okay, so we have this on the screen and it's gone. Hello Sarah-chan. No, she didn't come in the stream. She didn't come on the stream. She just on my desktop. Okay. So, in which language am I writing it? Like, I could just, well, SQL? I don't think SQL actually works. Oh, sorry. JavaScript? I don't think I can work with bits and bytes in JavaScript. I mean, I know how to do it, but it's not optimal. C, I don't have the C environment. Let's try that. So I have Python. Yeah, not Python. Well, yeah, it's Python 3. So I have Python. Python is actually, well, what? Wait, what? Exit. Okay, exit. I have Python. So well, I also have Node.js. But Node is JS, so I don't think I want to use it. Yeah, maybe Python. But Python is not very optimized with numbers. But we can have Panda. We can have NumPy. Yeah, NumPy is good. So let's do Python. Okay. Oops. If you want, if you were to find like, if you were to meet anyone that can be described as stupid yet genius, I think if that word exists, it describes basically me. So yeah, both stupid and like yeah, like let's go with 1 pixel then. Do you want to see 1 pixel? Well, wait. Oh, this one is radius. So 2 pixel is, well, it's pixel art. So 2 pixel isn't actually 2 pixels. Wait, what? 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 Hey. Sorry? Really? Brush preset. 2 options. 2 options. You get out and come here. Come. I said come here. What? Hey. Okay. Good. Feather 1. Yes, please. Feather 0. Close. Yeah, close everything. Just close everything. Oh. And oh. Wait, what is the shortcut for closing everything else? And why can I? Oh. Okay. I'm sorry. Okay, so this one is completely black. Oh my gosh. I will put these in draft folder, quick group, and drafts. Now, I don't want to zoom in so much, so okay, right about here. Okay, 2 pixel is good enough. Wait, is it radius? Yeah, it's radius. See? Oh, okay. Yep. So first, so project planning. Yeah, let's have the new layer, and we go with project planning. That was just the proposal. Now we are planning. Like, no, that was just the design. These are all proposals. Okay, so project plan. We will use tools. We are not going to use to say tool. We use a language, programming language. Programming language, Python. Well, Python 3, to be fair. So we will use NumPy. Which is the best mathematical functions for Python. For Python. Panda used NumPy. No. So how the data is stored? Data storage. What do you think? How should I store the data? I mean, I could use SQL, or just like just random binary file. Yeah, either of those. I don't think I should store it in like well, that actually works. Wait, what? JSON lie? Maybe? Yeah, I don't know. Like, I don't even know. Like, we'll see in the code. Development. Maybe the combinations of both. I mean, all of them. So programming language works. Data storage works. This is brain data storage. Brain. Now, what is What is the input and the output? So training. Data. I don't know. I really don't know which data to train. So it will be decide after development. So if you see a proposal that looks like this, mind you that the programmer don't even know what they are doing. I know. I actually know what I'm doing. I just know too much that I cannot decide at all what to do. I don't have a target. I don't have a target system. I don't have a target data. I only have the algorithm. So yeah, that's basically it. And by the way, I don't have to play games with my friend tonight, and I have no meeting. So yeah, that's all. Let's go. So project plan. How do I input the data? Well, we are working with streams, right? Let's go with the stream. So the system, the whole system will look like this. Input, stream, input stream, and yeah, input stream. How do I activate the data? How do I activate the brain? Well, we have this arrays of inputs. Well, so input stream will comes in arrays of bytes. Arrays of bytes. This is byte arrays. Byte arrays. So we want to read these byte arrays. Well, no, we don't. We just like use the index. Index. Yeah, IDX. The IDX of input is equals to node ID. Yeah. Remember when I was talking about how we should optimize? how we should optimize the calculations. Yes, well, we are not using node ID actually. We are not using IDX. So it should be IDX divided by 4 because we are using 32-bit numbers. Oh, I'm sorry. We are mostly looking for long int. Long int. What is long int? Long int is int 32. So it has 32 bits, or in this case 4 bytes. Yeah, 4 bytes. So this is unsigned long. U-long is C notation, by the way. It's a C modifier for unsigned long integer. Now this will become node ID. And so this is input node ID. Okay, so this is inputting functions. Oh, by the way, if it overflows on overflow, trigger high watermark. That's all. So what does high watermark means? High watermark events? Well, I just told you, the stream will halt. And how do we remove high watermark? Well, it will not be removed until the entire stream, the entire buffer is clear. It's called flushing. Hello, Jaya Dev. Welcome to my stream. This is part 3, and I just finished my design. Finished designing the system. But I still in the process of making a proposal to write this project. I'm not using existing ML library, by the way. I just use NumPy for long int in Python. What are we learning today? I don't know. I don't know if you learn anything. By the way, I just explained how data stream works maybe 20 minutes ago, and I am deciding like how neurons works. Digital neurons. We'll see. I'm not planning for anything. I'm not planning for teaching anyone. I am just showing off my idea. So if you think you can learn from it, good for you. So we have outputs 4 bytes for one node ID, and that's output stream. Let's look at the requirements. Okay, so we have to somehow store we have to for each node. Sorry. So node. Yeah. Node. We have ID, which is int32. And we will have threshold, activation threshold, which activation threshold. So assuming that a cell can connect to every other cells, and so this neuron, which is node, by the way, this neuron should have the same size as the ID. That's 32. That's in 32. We have 64 bits number now. Oh, by the way, I'm sorry. Why you long? Well, because 2 to the 32 is more than 1 million. That's all. That's all why I use 32 bits. 2 to the power of 32. Well, it's 4 billion. That's all. If I were to go with like like 2 to the power of 24, which is 3 bits, no 3 bytes. That's 10 million, but it's not optimized. Computer is not optimized to work with 3 bytes. So I go 4 bytes. I go with 4 bytes. So 2 to the power of 16. Well, can you imagine a living thing with 65,000 cells of its brain? I mean, it must be so stupid. That's all. So ID threshold. So each node should have activation state, which is AN actually. This one, I want 1 bit. The problem is computer is not optimized for 1 bit. So this is Boolean. What is Boolean, by the way? Boolean is 1 byte, but this byte can like work with other bytes, work with other Boolean bytes. So for 1 byte, for 1 byte, it can hold like 8 Booleans, depending on how the OS is allocating memory for it. So one byte, and it only cares about the last bit. So the entire data here is 65 bytes. Yeah, 65 bytes. Now we have to define synapse. Synapse. We have two choices of defining synapse. We can define it in like arrays of nodes, or we can define it as connections of nodes. For me, well, talking about space optimization, arrays of node optimize a lot, but it doesn't play well. It doesn't play well with the secret sauce, actually, functors. So how do we evaluate that? First of all, because this system is designed to reflect how nervous cells is actually work. Well, so for one cell, they have axons and they have dendrite. But the problem is we don't want to like define all the axons in all the dendrite. We don't want to define axons and dendrite for every nodes, but we want to define threshold. The node should know how many axons it has. Axon number. It is in 32 again, so now we don't have 65. We have, it's not bytes, it's bits. So now we have how many? 64 and and 96, 97 bytes. Bits. Sorry. Actually, it's not 97 bits. It is 12, 13 bytes. Yep. 13 bytes. Now we can define all connections here. Wait. Yeah, we could, but the reason we have axon num in node, not in synapse, because we don't want to count all the synapse. So I think it should be synapse pair, which means axons. So it means dendrite to axons pair. So dendrite which is node ID ID is uncapped, and axon is also node ID. Okay, so we have dendrite and axons. Now the signal strength, well, hold on. Should strength be in synapse or should strength be in node? Because if strength is in the node, it means we need to have an array of axons instead. So array of axons with strength, and then dendrite connects to axons. Which one is the best? I think, because if the strength, so strength, well, strength, it cannot be int, it cannot be integer, because this is multiplier, so it has to be float. But float is 32 bits, and if it multiplied by another 32 bits, well, maximum cannot be 1. So I think, well, yeah, just go with double precision. So double, double precision, which is 64 bits number. And yeah, we use double and integer. The decimal point will be truncated. That's all. So if the string becomes 0, everything dies. That's all. the synapse close and it dies. Strength. Yeah, I could just use in 32 and go with just 10 million cells. Nah. Really, strength is never more than 1, so it has to be, so it could be float. I'm not having any room for error here. So it's float 32. So this data, do we need more? Yeah, we don't need more. All right. So synapse. So we have 332 bits. So that's 12 bytes. Okay, so synapse, node and synapse. This is enough for an ML system. And we could just put these into SQL and let it work. But should I? Right. Oh. Should I go? Wait, what? Should I go with SQL? Synapse. Do I need synapse ID? Well, no, because dendrite and axons together makes synapse ID. Okay, so I forgot about that. This is primary key, so it's often say PK. Is that enough? Can we have a dendrite that connects to the same axon, like 2 dendrites connects to the same axon? Probably. But that is the strength. That is why we have strengths. So if we have 3 axons and we have if we have 2 axons and we have 3 dendrites connect to these two axons, 2 and 1. So the strength of one axon will be 0.3, the other will be 0.6. That's all. instead of having like well, to be fair, it's essentially the same thing. I mean, it occupies the same size. It occupies the same space, but having strength. Well, axon but yeah, axon works with threshold. But if that's so, if axon works with threshold, why don't we just use the strength? Hold on, let me think this through. So last time I argued this sigmoid functions. Let's look at that again. So sigmoid functions is this 1 over 1 plus e to the power of minus x. So sig x is n is like sig x is what? Oh, other property. Hold on. Oh yeah. It's this one. So it's 1 over 1 plus e to the power of minus x. Yeah, that's sigmoid. Power function is easier than division function, so I will accept power, but I won't accept division. Let's see. So sum of an divide sum of an divided by, yeah, it's the same thing. Sum of an divided by n every time, every activation versus n times strength times k strength times kn. Well, this one is easier. Well, kn is equal to 1 over n. No, actually not 1 over n. Kn is actually any bias. Okay, it's b then. Beta bias. Oops. Bias. So bias times activation equals to, yeah, compared to threshold. Sum of n. So yeah, strength. So this is activity. This is activity functions. Activation function. So this is activation functions. No, activity functions. It's not activation function. Activation function is activity less more than threshold. Activity activity functions. Okay, so this system cannot learn because we still cannot manipulate the strength. Axon number. Hey, wait, threshold and axon number. So we don't actually need axon number, right? We do need axon number, because if we don't have axon number, we cannot check if it's correct. So instead of string, I will say it's bias. Why don't I just use a larger one? Anyway, bias. Okay. Do we have to check? Because we have threshold here. Threshold can be changed, but axon number, well, axon number can be changed because axon number is a function of synapse. No, axon number cannot change. Synapse is function of axon number. So yeah, that's all. Now, how about our secret sauce, functor? Should we call functor, or should we call something like hormones, glands? Or yeah, I'll just call functor. Functor. So what is functor? Well, what does functor look like? It would be ID, which is I don't want it to have that much functor. I think int 16 is enough. Well, we can upgrade that. Okay, so functor functions, function. For function, we have two choices: either a script. So if we have script, we will need an API, or we could have like functions script. Yeah, we could have execution path, actually path to executable. Well, if we have path to executable, what will happen? It will call external functions that can do whatever it wants to the system. Yeah. But if we have the script, we will need to provide the API. Wait. My webcam turns on the light. I don't like it. So function script path to executable. How about script? Really, I want script, but scripting is hard. Like writing an entire interpreter. Well, I am an API engineer, so why not? Oh boy. I will have the script. I will have, yeah, and the script can call two paths. That is the best choice, because an API is the intent use, but executable might be better. Script. So this script can call executable. That's the base part. Executable. Oh, yeah. It has script, right? Mind you, the functor can create Stack Overflow. Now these functors, this is not like the entire description. Wait. Oh, functor. Yeah, we should have this 32 bits, because functor can not just like execute, but it can also, so the functor can also create another functor, can create functor. What does this mean? It means that I will use it as can be just residue. will also use it as the environment. So script. What is script? It's text file. So this one is 4 bytes. No, 4 plus X bytes, because, well, text file cannot exceed certain amount. I might limit it to like 16 bits, no, 16 bytes. I don't know. Or maybe I just decide it could be arbitrary part later. Anyway, 3 things, right? This is Turing complete, by the way, because it can create functor. If a functor can create functor, and a functor can also be residue, it basically means it can store data, and the functor can intercept nodes and synapse calculation. So it is flow control. Yeah, storing, fetch, store, fetching is, well, basic. So node activation activates functors. Oh, okay. So I have to note to myself, note so functor event, global functor event. Yeah, so I need to note to myself about global functor event loop. It's not loop, it's just event, because the entire system is in loop. Global functor event, wait. Oh, sorry. It's not note. It's a functor event. Functor events. Functor events or trigger, actually. Trigger. What is trigger? Trigger is trigger is just a description. It describes which node, no, which functor should be fired when the node is activated. And the functor can be arbitrary, can have arbitrary lifetime, like it can destroy itself. Can destroy functor. Yeah, so that's flow control. Trigger. Trigger. I think it should be it should be well, we should call this functor event, of course. Oops, wait, what? Oh, this event trigger. Trigger is node ID. That and trigger is node ID and target is functor ID. Oh. So this is 64 bytes. Also, the output, the snapshots or anything at all will, like the input functor, and that will be like input functor, output functor, snapshot functor. By the way, snapshot functor and output functor should be the same thing because we are working with data stream. Wait, how does my hand works like that? I don't like it. Yeah, that's enough. I think I will divide here. Oh, okay, and divide here. Okay, that's it. I will leave that there. Okay, alright. So, what does it look like in Python? No, not here. How can I, like, if I were to new file, new text, right? New file. What is this new file? What is new file in folder? What is the shortcut? Anyway. So no, I will put it in source src, and in this source folder it should be I don't know, main Python. Python main. Really, I didn't use it. Main configuration config parser main name. I don't use Python main that much, so wait, what does it use for? Main special name main is used for two important constructs. Your name top level can be checked using name equal to main, and the main.py is main.py is in Python packages. Okay. Should I see, scope of an interactive prompt mean it's main. Hello. Okay, so by using interactive prompt, this is main. Okay, so that's why I don't care much about main. So when did I use not main? Import this. Oh, Python code passed to the Python interpreter with C argument. What is it? What is C argument? Command. Okay. So Python module is passed to Python interpreter as file argument. Hold on. So so Python module is passed JavaScript debug terminal. No. Okay. Okay. So print. Oh, but it's Python 3, by the way. Python. What is this? src main.py. See, I don't use main because it's main. But in which case that we not writing outside? Yeah, in which case that we write outside main? Module can discover whether or not it is running in the top level environment by checking its own name, which allows common idiom for conditionally executing code when module is not initialized from an import statement. Wait, conditionally executing idiom for conditionally executing code when the module is not initialized from an import statement. if it's get imported, it will be run in its own environment, and it will be not main. So we can set name as something else. Huh. So this is not in main, but this is in main. Next section explain the use of sys.exit. I don't know. Next section, this package consideration. This is main.py in Python package. Well, then use to create command lines too by specifying them as entry points for console script. When this is done, pip inserts the function call into a template script where the return value of main is passed into this thing. Okay, return value of this main. Okay, return value of main. Often. So since the call to main is wrapped in sysexit, is that you return some value acceptable as an input to sysexit. Typically an integer or none, which is implicitly returned if your function does not have a return statement. So this makes Python C. Okay. So main is top level. Outside main is not top level. Outside main is, I don't know. It doesn't make sense. So this file don't have this kept short and import functions to execute from other module. Kept short and import functions to execute from other module. Those other modules can then be easily unit tested and are properly reusable if used, and if main block will still works as expected for main apply within a package, but its name attribute will include packages path if imported. Oh, okay, this one will file in the root directory of a zip file, though hence for consistency minimal main like Reinvent mentioned below I prefer. In standard library, it doesn't contain if, but you can invoke it at Reinvent what? Virtual environment. Okay. Oh yeah, by the way, in developing Python, you should use virtual environment, but I don't. Sorry, I don't know why I don't, but I just don't. I mean, I didn't learn about that. I didn't even learn about main. Python program was started with the other module running with that same program can import top level scope. By importing main module, this doesn't import a main.py file, but rather whichever module that receive the special name main. What? Namely, import main name main exit. So define the variable my name. Now we started our program. The result will look like this. Hey. Start.py. This is start.py. Import from namely, and the what is this? Dincel. Start.py. This is namely. So what is this? My name, and this is my name. File variable my name. Did user define the name? Okay. Wait. Importing main doesn't cause this unintentional running top level code mean for script. So scripts use, that's why script use main. But if we don't, okay, which is put in a main block of the start module. Oh, wait, start exit main. Main this. Oh, it doesn't invoke this one. Print. Where's print username? It doesn't exist anyway. So Python inserts an empty main module in sys module, adding the previous startup, and populates by running top level code. Oh, in the example, for turn Okay, so line by line imports, namely in turn, namely imports main, which is really start. That's an import cycle. Fortunately, since partially populated main module is presented here, Python pass that namely namely on how so repo of top level environment, so anything defined in repo becomes part of the main scope. So if we wait, so this is print name, but if we use if name equals to what, main print not name, and then yeah, both of them. So why? Oh, maybe. So if I say define print name that and then we print the name, this won't work. Oops. How? Oh, I know why it works, because repo is name and this thing isn't imported. Okay. So why do we use sys exit? Anyway, doesn't matter. Okay, so let's define our class. Python class. Now, built-in exceptions. How many classes? Abstract class. ABC. Abstract base class. Wait, what? Yeah, built-in type. Built-in exceptions. Context manager, binary data service. Oh, what? Interpret bytes as packed binary data. Oh, this is actually quite good. We don't need numpy then. Codex. Registry and base classes in code. Oh, okay. Vital order. Well, I will use numpy anyway. What the fuck is Unix database? Okay. Understandable. SQLite. SQLite is the library. Do I need to pip install it? Okay, so range, number, flow control. Wait. Flow control. Okay, data structure, tuples, loop, dictionaries. How do you define a class? Classes, yes. Wait, what? Namespace. Oh, so name is namespace. Oh, a word about name and objects. Nah. Scope and namespace. Okay. Yeah, maybe. Scope taste, local spam. Yeah, local spam. Class name, class statements, class object. Define statement. Okay, this is something that understandable. Decorators define function name, type parameters, parameter, and then output an expression. Okay. Wait. Oh, okay. This is funcdef. Parameter lists. Wait. Decorator. What? Like function definitions must be executed before they have any effect. You could conceivably place a class definition in a branch of an if statement or inside a function. In practice, is when inside class will usually be function definitions, but other statements are allowed and sometimes useful. We'll come back later. Oh, I'm going now. Instance object. Class complex definition. Def in itself. What? If a class may define special method name init. So this is constructor. Okay. Okay, so this is constructor. Are we using tuple instead? Pigs. Wait, what? Why do you put ticks in the dog? You crew. You put ticks in the dog. Wait, what? Strings instance or okay, class name instance unique to each instance class. As discussed, whether names shared can have possibly surprising effect involving mutable objects such as those. But should not be used as class variable because just a single list would be shared by all dog instances. Why did I do this? This is a static. This is static. Okay. So this is just saying that it's a static class. Oh, so how? Oh, so this is not static class. This is constructor. Okay. Okay, so we will do this. Hey. Alright. Yeah, we will do that. Oh, we don't have print name anymore, so let's just delete it. And now we have class. One problem. I think it should be this, and then you go there, you go there. Oh no, not there, there. Okay, class. Oh, where is it? Okay. It should be this one. So let's make it quick. Export it real quick. Design. Oh. Sorry. Oops. Which one? Okay. This. Right. Alright. Now we can read all these. Oh. Come on. Anyway. We have class node, which actually neurons neuron define init where's underscore define init self and iter. Wait, what? Do I actually have to have iterable self? Okay, self. Okay, just self first. because we don't have list here. We could have lists, but I think no. Sorry, it has to be this. Self dot ID. Yeah, self.id equals to 0. Self dot threshold equals to 0. Self dot state go to false. Wait, why do I put semicolons? Self dot what is that? Axon number? Axon num equals to 0. No connection. Okay. That's neuron. Class synapse. Define init self self that then write write 0 self that action equals to 0 self dot bias equals to 0. Oops. Class functor oops define init self self dot id equals to 0 self dot instead of function I think I will say well yeah function is it callback? No, it's not callback. I don't say callback. So function or script? Well, it will be script. Equals to something. Class event oops define init self dot trigger well 0 self dot target I think I have problem now because all I do here is SQL So maybe go with SQLite. Where's SQLite? Okay, so Python SQLite. SQLite. Yeah, let's go with tutorial. Wait, is it the same? Yeah, it's the same website. It's the same web page. So connect tutorial DB. So connect. Wait. Okay, I will use W3. That's too bright. Sorry. SQLite. Oh, that's not too bright. Should I do that though? I literally have this one. I literally have this. I have MySQL, MySQL in my local web server. So why should I use SQLite? Other than it integrates in, yeah, if it's just standalone, I will use it. This is standalone, self-contained. This is what I'm talking about. Wait, what happened in 2050? So that's 26. What? 2026 is in the future? What? Wait, what? Oh, it's not. Sorry, my math. Alright. This minus 34. Okay, 2016. Cross-platform code. Yeah, aviation grade testing. Well, it's still 20 years away. Right. Okay. Okay. So source code is here. I don't care though. What is the release? Wait, yeah, just use it. Should I? snapshot. Oh, this is source code format. So DLL. Wait. Let me try this. Python include. No, import. Sorry. Import SQLite 3. So it just works. I'll just use it then. Wait. Create new database connection. Go to create connection to the database to the DB in the current working directory. Implicitly creating it if it doesn't exist. Okay, so this line is something. Okay, so let's go to the top and import SQLite 3. And then yeah, this thing is, I mean, they are database. They're just database. Because if it's not database, this thing shouldn't be ID. Well, it should be ID. But this dendrite say it should be new run. Wait, how do you say that? How do you make instance? How do you make an empty instance of a class? Class is empty instance. Wait, can I just new run this? No. How is empty class? It should work. Complex, okay. Counter. Name equal to name. Okay. Okay. So this should be ID equals to ID. Threshold equals to threshold, which I think, well, I will say that later. State. Wait, false is capital F. State equals to false. Threshold should be how do you get max int? Well, 2 to the power of 16 minus 1. That's half. Axon num. Yeah, axon num. Oh, I don't have the formatter. What the hell? Axon num equals to 0. Python? Oh, okay. Axon num. What? Why is this highlighted? So neuron 1, like This should work, right? Hmm. Yeah, it should work. Formatter. Wait, what? This doesn't format. Wait, what? Wait, I think I already installed. Yeah, it's already installed. So, I think I have to restart. I have to restart the editor. Where is it? Where's the? Wait, it should be here. Whoa. To be fair, let's copy this and let's comment it. No. Okay, so that's how it works. Now, should I use SQL? Should I use SQLite, or should I have? Or should I have my? Or should I use objects? Forgot about that. So is it all referenced? I think it's not referenced, but it's garbage collector, so it must be referenced. Wait, how did it pass data? Passing data. Does it have any? anything can that can tell me how data structure. You know, I gave up Python. Yeah, so it's passed by data. Wait, not passed by data. What is that? It's called passed by value. Python. Yeah, so you know, if we see passing by data by default, we can just use arrays to pass. So what is best practice? You know what? If you pass something in wait, let's try that. Suppose we have a equal to 16, then we have define add x y. Return actually yeah well, so my RAM was like choke a bit. Define x and y. A equals to a plus x. See, it doesn't work. Why? Because it doesn't know a. You use global a, like n square n. Yeah, this doesn't work. Ugh. Define x equal to x plus y. What? Indentation? What the hell? So if we say add 10, 3, should be third. Yeah, it shouldn't return anything. But if we say add, yeah, sorry, we have A, and if we say A add 3, nothing else, nothing happens, right? But what happened if we say this? Like, see? What happened if we say add, define add, how do you say? Oh, this doesn't work. A equal to this, B equal to 0, and then a 0 equals to a 0 plus b, and then we have we cannot do this anymore because type error. But if we do no, okay, if we do this, it works, right? So this should work. Okay, it doesn't work. It's actually good. So wait, what happened if I have b dot wow equals to, yeah, equals to 3? No, b equal to, what is an empty object? How do you define empty object? Wait. How do you define an empty object? That's the dictionary. How do you define an empty object? That's strange. There's an empty object. Really? Wait. There is an empty object. Wait, that exists now. That exists now. But what is an empty object? Wait. Okay, that's tuple. So B equals to object. I don't think that works. So what is it? Object. Yeah. So how do you do that? It says it springs into existence, isn't it? So why it doesn't do that? This is object lesson. I'm not talking about that. I'm talking about just empty object. Doesn't exist. Wow. Wait. I thought I know Python. Hold on. Yeah, it's basically data class. Okay, so instead of empty object, Python has null. Like oops. No, it has none. But the problem is none does have val. Which is annoying because I forgot about that. I can just do this. Right, and we have C. That doesn't work, right? But if we use this is tuple. So it works. Wait. How do you define tuple? Oh. Yeah. How many years that I didn't talk about this? Name V is not defined? What? This is associate array, by the way. What? Oh. Wait, what? Wait, this is strange. It's data delete. How do I say this? Oh. I mean, that works, but not as I wanted. Anyway, how about we add, wait, we should define add again. Add object A, B, A, well, add B, so add object A, no, B to B. Yeah, this works. This is passed by reference. So if we pass object, it passed by reference. That's cool. Okay. I think I should go to bed. I'm sorry. What's my friends up to? Nothing. Okay. Yeah. Pass by reference means it will it will cap at the number of memory. So my system is 64 bits. So if I have more than 2 to the power of 64 neurons, it will break. It will break, which according to the design, no, we don't have that. Wait, not 64 bytes, that's 64 bits. We don't ever had any info that surpass 64 bits. So might as well just do that and maybe think data storage is actually better. Should we scrap this? Should we scrap this? No. Wait, bias is actually one F. Should we? I still don't know. Sorry, but hey, guys, go down here. Yep, you guys. Nope. ID, which must be stated. And then script, which is like doing nothing. And the event trigger, yeah, trigger and target. Yeah. I wish I had C environment at this point. Anyway, it works now. So if we have yeah, K equals to neuron 1 with no threshold. and we have no, actually N. And then we have synapse with dendrite, any int no, not self, dendrite is int, and axon int, bias I think float is enough. ID become int, script becomes string, str, sorry. Target trigger is int, and target is int. Okay, so threshold is int, and state is boolean. Axon num is int. Yep. Now we have synapse int. Oh, we need 2 neurons. N1, N2 goes to neuron 2. Synapse. We have 1 to 2 with bias of 1, and we have functor with ID of 1, and event with event, wait, sorry, this should be functor event. Functor event is trigger. The ID could be 0. Anyway. Print N1 object separator that. Well, of course I'm not doing that. Print string inserted between values. Wait, values is star. Hold on. So this works. N1. N2. S. Oops, S. F. E. Okay, so yeah. Do we have two string here? Do we have this? We don't have. Wait, what? Class format get hash. Wait, size of string. Oops. Let's get that. Method string wrapper. Sorry. Yeah, so we cannot use implicit that class deconstruction, I guess. Let's try that again. Okay, so no, we cannot use explicit class deconstruction. Anyway, we know that works, right? Oops. Yeah, at this point, we still can initiate the same primary key, the same ID to things. But I think I will leave that for today. It's like 2 hours, no, actually 4 hours. And it was supposed to be like 2 hours every day, every evening. But here we are. Next time we will be using SQLite to help with writing our AI, and it will be fun, so fun, because the reason why I don't use object to write the entire AI system, because I want the ID. So the ID is that I mean, the ID cannot be identical. It should be unique. So trying to enforce that on objects is not gonna work. You still have to like find some data table. Yeah. So instead of just write the data table myself, I just use SQLite, because SQLite is an app for, I mean, SQL is a language for data table. So next time we will be writing Python SQLite 3. Now we will have to leave. See you later. Oh, Bye.